So we left off in the last section by asking how we can compute this thing's called importance for a given number of web pages based upon their connections to one another. And before we delve into the specifics of that, we should step back and really analyze the structure of something called a web graph. So in order to understand what a web graph is, we should first talk about what a graph is. And a graph is actually a mathematical structure. So we're not talking about an XY plot of some function. We're actually talking about a structure which consists of a set of vertices or nodes. So those are vertices. And also it consists of a number of edges or links that connect them. So vertices are represented as circles. So maybe we have 3 vertices or nodes, as we're going to call them, in this graph, and there's some amount of connection between them, right? And these connections we would put as arrows on there. So if this node points to this node, then there would be a link or an edge link from this node to this node with an arrow pointed this way, indicating that, well, A points to B, B does not necessarily point to A. And so now a web graph is just a specific type of graph, really. And so in this case, the nodes that we're looking at are the web pages themselves. And the links we're looking at are these things called hyperlinks. And if you recall, a hyperlink is basically a reference to some external content from on a web page. So if we're on a page and we see some line that has a URL on it that points us then to another web page, this is a hyperlink, and we could say that this page has a connection pointing to this page. And now it's important to realize that in this case the graph is again directed, which means that just because our page points to this other page does not mean that this page is necessarily going to point back to us. So for instance, if this is our own personal page and this is Wikipedia, just because we have a reference to Wikipedia does not mean that Wikipedia is going to have a reference to us. So it's important to keep that in mind. And so this is an example of a web graph that we're going to be looking at in this section, which consists of 4 nodes. We have node W, node X, node Y, and node Z, and some connections between them. So for instance, W points to X and points to Y, so there's a hyperlink on page W to X and Y. From Y, there's a hyperlink to this page Z, and so on and so forth. And so we have to ask ourselves the question, what makes a page important? So perhaps we might say that importance comes from this notion of in degree. In degree. And the in degree is basically the number of incoming connections. So if we look at node W, W has an in degree of 1 because it has one page pointed from Z. X has an in degree of 2 because it has a link from W and a link from Z. Y has an in degree of 3 because it has a link from each of the other nodes. And Z has an in degree of 2 from Y and X. So by this logic, Y would be the most important node because it's the most commonly cited. X and Z would tie for second place, and W would be third. But the question is this really the way that we should do it? Is this really the right notion of importance? And as it turns out, Google does not think that in degree is enough to represent the importance of web pages. And we will look at that throughout the rest of the section.